Hello, my name is Sylvia Vassileva and I will present our team's approach for solving the SympTEMIST shared task. Our paper is called Transformer-Based Approach for Symptom Recognition and Linking. The SympTEMIST shared task is a challenge to extract and normalize symptoms, signs and findings from Spanish clinical reports. There are 3 subtasks and our team participated in 2 of them. Subtask 1, named entity recognition of symptoms, and subtask 2, linking these symptoms to the correct SNOMED CT codes. The dataset contains 1000 documents in total, split in train and test sets. The train set has 750 documents and the test set has 250. The organizers also provide the gazetteer of terms and their SNOMED CT codes, which contains the set of codes for the entity linking task. In addition to the SympTEMIST dataset, we used UMLS to build a knowledge base of about 290,000 symptom aliases. All aliases in UMLS Spanish SNOMED CT, which correspond to codes found in the SympTEMIST gazetteer, combined with the gazetteer and train set mentions. Here is an example of a labeled sentence from a clinical report. It has one complex description of a symptom, proliferation and dilation, even cystic, of the bile ducts, corresponding to the SNOMED concept cystic dilation of intrahepatic duct. Each subtask is addressed by a different model in our system. First, the clinical report is split into separate sentences. For each sentence, the symptoms are identified using a BERT-based token classifier. And finally, each symptom is linked to the appropriate SNOMED CT code from the gazetteer using a cross-lingual SapBERT. Our system uses a BERT-based token classifier with a 2-layer bidirectional LSTM and conditional random field layers to identify the symptoms in the sentences. We apply data augmentation to the train set by replacing entity mentions with synonyms from the Spanish UMLS to generate about 1700 new sentences. We experiment with Spanish RoBERTa and ClinXS models, which are pre-trained on Spanish biomedical and clinical texts. We fine-tune the different models for token classification and evaluate the effect of using the bidirectional LSTM layers. The evaluation results for subtask 1 show that adding the bidirectional LSTM scores the highest F1 on the test set, and second highest on the validation set. The Spanish RoBERTa model shows the best results for both validation and test, while ClinXS results are slightly lower but still higher than 70% F1 score. For subtask 2, the system performs linking in 2 steps. First, we try to match the mention to an alias in the knowledge base using dictionary search, and second, we use cosine similarity search on the SapBERT XLMR-Large embeddings and retrieve the closest alias in the knowledge base. We perform several experiments with different knowledge bases, but the best results on the test set are achieved using the UMLS knowledge base, which shows an accuracy of 58.9%. After the training dataset is split into sentences, it is augmented by randomly replacing some of the annotated mentions with a synonym from the Spanish UMLS. This increases the total number of train set sentences to about 13,500. We use the augmented train set to fine-tune the named entity recognition models, and here is an example of an augmented sentence where the synonym is replaced with another one from UMLS. Fine-tuning using the augmented train set significantly improves the precision and F1 of the Spanish RoBERTa model, and we observe a performance drop in the augmented ClinXS model compared to its non-augmented version of the validation set. However, on the test set, the 2 models are close in terms of F1 score. The augmented Spanish RoBERTa shows the best results on both the validation and test set consistently. As a conclusion, augmenting the dataset and adding bidirectional LSTM layers improves the performance of the named entity recognition task. The choice of knowledge base is important, and using additional UMLS terms helps improve accuracy for entity linking. Our best score on the named entity recognition task is 73.2% F1 and 58.9% accuracy on the entity linking, which is ranked second for this subtask. Thank you for your attention. Feel free to reach out via email if you have any questions.